And another word for congruence transformations that you might see are called rigid transformations. So I'm going to add the word rigid. We're going to be looking at different polygons that would be on a graph, and we're going to do a transformation to change that polygon and place it in a new location. We'll do that because we're going to change the position or location of what is called a pre-image, which is just the polygon that you're going to have graphed on some coordinate plane. What you start with, that's your pre-image. And we're going to take a pre-image or something that you're given on a graph, and you're going to change it and put it in some new location. And one of the ways that we write that this has happened is that we take our pre-image, which we might list the name of a polygon like triangle ABC. We put an arrow to show that it is changed into our new image. And we'll see an example of that in a minute. But your pre-image is your original polygon that you're going to see on your graph. And we're going to be focused on 3 types of congruence or rigid transformations. Okay, one of the first types of transformations we're going to look at is called a reflection. And a reflection is kind of like a flip. If you reflect something, you're going to flip it. So when we do a reflection, we're going to flip the pre-image over a line of reflection. So to do that, we're going to have a graph, and on the graph, I'm going to show you where your pre-image is located, where those vertices of that polygon are located, and then we're going to flip it on our graph over some imaginary line that we have. So start by creating a graph. It's just a rough sketch. Give your graph a scale. All right. We are going to reflect some triangle ABC over the y-axis. When we do that, we'll have triangle ABC, our pre-image, and it will become a new triangle that we will label A prime, B prime, C prime to show us our old point A, our old point B, our old point C, and our new point A, our new point B, our new point C. And that is going to be our new image. So point A is located at -1, 2. Point B is located at -1, 4. And point C is located at -3, 2. We're going to create our new image by reflecting this over the y-axis. And after we reflect it over the y-axis, we will label our new points A prime, B prime, C prime on our graph, and we will write down what those points are right here. So on our graph, point A is at negative 1, 2. I'm going to find that. I'm going to label it point A. Point B is at negative 1, 4. And point C is at negative 3, 2. Once you have all those points, create the sides of your polygon, which is our triangle here. And then we're going to reflect that over the y-axis. So when we do that, we say, okay, if I pick this triangle up and I were to flip it to the other side, where is it going to be located? So every single vertex for this polygon is a certain distance to the left of the y-axis. When we flip it, all of those points become a certain distance to the right of the y-axis. So I look at point A and I say it is 1 unit to the left of the y-axis. So I'm going to keep level with where point A is, but I'm going to go 1 unit to the right of the y-axis and label my new point A, and the new one we call A prime. It's not the same point A, it's our new point A. And then I look at point B and I say it's 1 unit to the left of the y-axis. So for point B, I go 1 unit to the right of the y-axis, and I label that point B prime. And then last, I look at point C and I say, hey, point C is 1, 2, 3 units to the left of the y-axis. So I'm going to go out 1, 2, 3 units to the right of the y-axis and label that point C prime. Draw in your new triangle. Take a colored pencil and shade that in so I can see my new image. It's triangle A prime, B prime, C prime. It's my image. And then I'm going to take my new image and I'm going to label all of those vertices. I'm going to write them down and say what they are. So point A prime is now at the location 1, 2. Point B prime is at the location 1, 4. And C prime is at the location 3, 2. This is just a rough sketch and notes. If you're doing homework or you're doing a quiz or a test or some other assignment, you need to be using real graph paper, but these are just a rough sketch for notes. And if we look at all of these points, they should all follow the same pattern from the pre-image to the image. The only thing that has changed in all of my points is that all my x values changed sign. They were negative, now they're positive. And if you think about that, flipping something over the y-axis here, or over this line in the middle, the only thing that changes when I flip it is my x values go from negative over here to being positive over here. So that makes sense. And you can kind of check that to see if it follows that same pattern for all of your points. There are other reflections you could do, like I could reflect this over the x-axis, which means my y values up here would go from positive to being negative down here. But they would all follow that same pattern for whichever direction you flip it or reflect it. Another transformation would be a translation, and we can also call that a slide. Since we're going to slide all vertices or all points from the pre-image in the same direction and the same distance to create our new image. And the way that we know how we make this slide or how we make this translation, how we move it a certain direction and how far we move it, is we use something that's called a translation vector. The translation vector tells us what direction we slide and how far. It almost looks like a point, but it's not a point. You will see these arrows look like less than, greater than signs instead of parentheses. And the reason I say it's like a point is you're going to have some number, I'm going to call it A. It's going to be some number, any number, and then a comma and some other number, let's call it B, but it's just some number. And the one that comes first tells you how you move your X values right or left, just like that would be the X in a point. And the second one, B, would tell you how you move your Y values up or down, just like that would be a Y value in a point. So we want to write that down so we can remember that. First number tells you how to move X values, which will either be left or right. And the second one tells you how to move Y values, which will either be up or down. So we're going to make another graph. It's just a sketch. Give it a scale. We're again going to have a triangle ABC, our pre-image, and our new image is going to be triangle A prime, B prime, C prime. Point A is at 1, -2. Point B is at 3, -3. And point C is at 1, -4. So I'll be given those points for the pre-image, or I'll already have it on the graph. So we're going to put those points there for our pre-image to see where that's located. So A was at 1, -2. B was at 3, -3. And C was at 1, -4. So sketch that out. Here's our pre-image. And then you're going to be given this right here. You're going to be given a translation vector that will tell you how to move, what direction, and how far to get your new image. So if my translation vector gives me the numbers -2 and 3, that means since -2 is in the X location, and it's negative, that tells me I'm going to move left 2 spaces. And since 3 is in the y location, that tells me that I'm going to move up 3 spaces. So I'm going to look at every single point. We're going to slide all points from the pre-image in the same direction in the same distance. So start with point A. I'm going to go left 2 spaces, and I'm going to go up 3 spaces from my new point A, which we call A prime. So left 2 spaces, up 3 spaces, and then right here, I have that point A prime. And then for B, go to it. I'm going to count that left 2 spaces, and then up 1, 2, 3 spaces, and there's my new point B, which I call B prime. And then for point C, I'm going to go left 2 spaces and up 3 spaces, and there's my new point C, which I'm going to call C prime. I connect all of those vertices or all of those points for my new triangle. And right there in blue is my new image. It's my new A prime, B prime, C prime triangle. And then write down all of your new points. So point A prime is now located at -1, 1. Point B prime is now located at 1, 0. And point C prime is now located at -1, -1. Now, one thing you can look at with this that's really neat, it's not just that it tells you how to move on a graph, and you can look at the graph, you can physically take your pen or your pencil and you can move it that many spaces and see the new point. I can also look at the numbers here. My x values were supposed to go left 2. So if I take the number 1 for my x value for A and I subtract 2, I end up with -1. If I take 3, the x value for B, and I subtract 2, I get +1. If I take 1, the x value for C, and I subtract 2, I get -1. My y's were supposed to go up 3. So if I take this y value -2 and I add 3, I get 1. If I take this -3 and I add 3, I get 0. And if I take that -4 and I add 3, I get -1. So if you like to graph it first and look at the graph and say, I'm going to move left 2 spaces, up 3 spaces, plot the new point, and then write the new points down, you can do that. If instead you want to write all of the points first by adding or subtracting the numbers to x, adding or subtracting the numbers to y, then with your new points that you wrote down, then graph that, you can do that as well. But you want to check both and make sure that on your image, on the graph, it has moved to the direction it's supposed to, and then make sure with your points, the x and y values have changed like this, like they're supposed to. So you have 2 places you can check to make sure that your answer is correct. Okay? And that's a translation or a slide. All right, the third type of translation we're going to look at is called a rotation. Or turn. Rotation is when you turn around a fixed point called the center of rotation. You will turn in degrees. And right now we are only going to focus on 90 degrees, 180 degrees, or 270 degrees. And when you turn, you can also turn in directions. Which will be counterclockwise or clockwise. So if you turn counterclockwise, you're going the opposite direction of a clock. So the opposite direction of the second hand on a clock. So you're going to be taking your direction and turning it this way. If you go clockwise, you do go in the direction of a clock, just like the second hand. And you're going to be turning that way. Okay, as we do these, you're going to have a guide for how to change your points to be in the new locations to do these types of rotations. And for us, the fixed point called the center of rotation, we're going to be rotating around the origin, meaning the point 0, 0. We're going to be rotating around just the very center of our graph. Right? So for doing that, I'm going to give you possibly a 90-degree rotation. Counterclockwise. You'll take your old point, X, Y, and you're going to change that point by writing the opposite sign of your Y value first and your X value second. So for example, if I gave you the point 3, -5, the opposite sign of your Y value that you would write first would be the opposite of -5 or +5. And then your X value next, 3. You might have a 180-degree rotation. And that doesn't matter whether you go clockwise or counterclockwise. If you go 180 degrees, you're rotating around through an entire line. So I would go here to here, my pen pointing down. Or in the other direction, I would go here to here with my pen pointing down. Doesn't matter whether I rotate 180 degrees clockwise or counterclockwise, you end up in the same location. So 180-degree rotation, you won't necessarily see a direction. If you do, it doesn't matter. It takes you to the same place. So if 180-degree rotation is there, you have your original point X, Y, and you change the sign of both numbers in your point. So if you had 3, -5, you change the sign on your X to make it -3, and you change the sign on your Y to make it +5. Then there's a 270-degree rotation. So if I give you that counterclockwise, you have your original point, X and Y. You'll write your Y value first, and your x value second, but the x value will change sign. So if I give you the point 3, -5, I will first write down the same y value, -5, and then I write down my x, but I change the sign to make it -3. And I would do whichever one of these kind of rotations I'm trying to do, I would do that for all of my points from my pre-image to my new image, and then I would graph it. So for all of those, you want to write the new points first, and then graph. All right, we will come back tomorrow and do an example of some rotations, and then get some good practice in with identifying different types of transformations, either a reflection, a translation, or a rotation, and then you'll be graphing a lot of those to create those transformations.